All right, everyone, buckle up because today we're diving deep into something pretty incredible.
Yeah, this is gonna be a fun one.
It really is. We're talking about CLIP.
CLIP.
And if you're even remotely into AI or just like how computers are starting to understand our world better,
hmm
you are going to want to listen to this.
Absolutely. So CLIP, that stands for Contrastive Language Image Pre-training. And
Okay, wait, right there already.
baby.
I know a lot of our listeners are pretty tech savvy, but even I'm like, contrastive language, what now? So,
Right.
for those of us who maybe haven't been living and breathing AI papers lately, can you give us like the elevator pitch for what CLIP is?
Sure. So basically, CLIP is this neural network that's learning to see the world more like humans do. And it
Right.
does that by using language.
So instead of like feeding it tons and tons of labeled images, like this is a cat, this is a dog, it's actually learning from text descriptions.
Exactly. It's like if you learned about different animals by reading about them
Yeah.
instead of just looking at pictures.
Which is kind of wild when you think about it. Like computers are getting closer and closer to how we learn.
It really is a big deal. And the thing that blew me away when I first read about CLIP was this idea of zero-shot image classification.
Okay, yeah, the article we're looking at today definitely dives into that. And that's like the holy grail, right? Being able
Yeah.
to recognize something you've never seen before.
Right, and CLIP can actually do that. Like imagine you showed a picture of a platypus, which is already a pretty weird animal.
I mean, half bird, half mammal, half something else, who even knows?
Exactly. But even if CLIT has never seen a platypus before, if you give it a description like egg-laying mammal with a duckbill, it can actually figure out that's what's in the picture.
That's mind-blowing.
Yeah.
So how is CLIP actually doing that? Like, what's the magic behind it?
Well, a lot of the magic comes from this thing called contrastive learning, which you mentioned earlier.
Okay, yeah, the article kind of glosses over it. So can you break it down for us?
Sure. So think of it this way. CLIP is basically playing a massive matching game with images and text descriptions. So it's given like millions and millions of these pairs.
Like a picture of a dog and the text dog.
Right. And then maybe a picture of a cat with the text apple. And CLIP has to learn to tell which pairs match and which don't.
So it's figuring out that dog goes with a picture of a dog and apple doesn't.
Exactly. And by doing this over and over again with tons of different images and descriptions, it starts to build up this understanding of what different concepts look like.
So it's not just memorizing specific images,
Mm.
it's learning the concept of dog or apple.
Precisely. It's learning the relationship between the visual information in the picture and the meaning of the words.
That is so cool. Okay, so we've got contrastive learning happening, but then the article throws another curveball. It mentions this thing called dual encoder architecture, and now I'm really lost.
Yeah, that sounds complicated, but it's actually a pretty elegant idea. So think of it this way. CLIP has two main parts, or encoders,
Two encoders,
one for images and one for text. And they each have their own specialty.
like a detective duo.
Exactly. The image encoder is like the visual expert. It analyzes the picture, looking at things like shapes, colors, textures, all those visual details.
Okay, so it's breaking down the image into its core visual elements.
Right. And then you have the text encoder, which is like the language whiz. It analyzes the words in the description, figuring out their meaning and how they relate to each other.
So we've got one encoder looking at what the image looks like and the other looking at what the words mean.
Right. And here's the key part. These two encoders are working together. They're constantly comparing notes, seeing if the visual information from the image matches up with the meaning of the words.
It's like they're both trying to solve the same puzzle from different angles.
Exactly. And if the pieces fit, if the visual clues from the image align with the meaning of the words, then CLIP knows it's on the right track.
So it's like this incredible collaboration between visual analysis and language processing.
Yes. And the thing that makes CLIP so powerful is the sheer scale of the data it was trained on. We're talking 400 million image text pairs.
400 million. That's like if you spent your entire life just looking at pictures and reading descriptions.
It's mind-boggling. And that massive data set is what allows CLIP to learn such a diverse range of concepts.
Okay, enough about the technical stuff. Let's talk about what CLIP can actually do, because I feel like this has huge implications for like everything.
Oh, absolutely. So one of the most exciting applications is zero-shot image classification, which we touched on earlier.
The being able to recognize images is never seen before.
Exactly. So imagine you could search your entire photo library using natural language descriptions like pictures of my dog wearing a hat.
Or that one time I went hiking and there was that amazing sunset.
Exactly. You wouldn't have to tag every single photo or remember specific keywords. CLIP could just understand what you're looking for.
That would change my life. My photo library is a disaster.
Mine too. And this has huge implications for online image search as well. Instead of relying on keywords, you could search using detailed descriptions.
Like a photo of a cat riding a unicorn on a beach with a rainbow in the background.
And CLIP could actually find images that match that description.
That's insane. Okay, so image search is one thing, but the article also mentions this idea of text-to-image generation, which is like something out of science fiction.
Right, and CLP is actually the foundation for some of the most advanced text-to-image models out there, like DALL-E.
DALL-E, the one that can create images from crazy prompts, like a walrus wearing a tutu playing the drums.
Exactly. And it's all thanks to CLP's ability to understand the relationship between images and text.
So CLP is not just changing how computers see, it's also changing how they create.
And this has huge implications for art design, advertising, all sorts of creative fields.
It's really blurring the lines between human creativity and artificial intelligence.
It really is. And this leads to a question that I've been thinking about a lot. If CLP can learn visual concepts from language, could it actually teach us something about how our own brains work?
Oh, that's a deep one.
Like, could studying CLIP's ability to connect images and text give us insights into how our own visual and language systems interact?
That's a question I don't think anyone has the answer to yet, but it's definitely something worth pondering.
Definitely. And it just shows how CLIP is pushing the boundaries of what we thought was possible with AI.
So listeners, if you're interested in the future of AI, if you're fascinated by how computers are starting to understand our world, I highly recommend checking out CLIP.
It's one of the most exciting developments in AI in recent years, and it's just the tip of the iceberg.
Who knows what amazing and maybe even a little unsettling things we'll discover as we continue to explore the potential of CLIP.
That's the fun part. We get to watch it all unfold.
All right, folks, that's it for our deep dive into CLIP. Thanks for listening.
Thanks for having me. This was awesome.